Namaste and good afternoon to everybody. Welcome to the, I think the almost last session of the day. I would like to now invite Mr. KRS Narayan. I request Dr. Dharamveer Singh from IIT Mumbai to please come on stage. I request Dr. Vishal Thombare, Executive Engineer, Mumbai Municipal Corporation, to please come on stage. For the start, instead of me introducing, I will ask my co-panelists to introduce themselves and then I'll start.
Thank you, Dr. Yogini. We have 3 doctors here. I'm the only fellow who's not a doctor. So, thanks for... My name is KRS Narayan. I'm a concrete technologist. I've spent 34 years with concrete. I've lived, breathed concrete. And I'm working in Reliance Industries. I'm currently leading CCUS strategy for Reliance Industries, especially the CCUS mission, the net zero plan of Reliance Industries 2035. And fairly interested in working in roads, new materials, basically carbon materials, carbon capture, utilization of carbon dioxide in cement and concrete, which is the low-hanging fruit.
Yeah, good afternoon one and all. I am Dr. Vishal Thombare. I had done my PhD from IIT Bombay. I am working in Brihan Mumbai Municipal Corporation since 1997. Recently we had completed Costal Road project, which I was one of the team engineer right from start up to, we had completed almost 95% of work. Now I am working in concrete road planning division, constructing concrete roads all over Mumbai. Our vision is to make Mumbai city pothole free. Thank you so much.
Yeah, good afternoon all. Myself, Professor Dharamveer Singh from IIT Bombay. And I work in area of road constructions and quality controls and the failures. And we do support nationally, internationally. For example, NHI, then local bodies, and then both kind of roads actually. Like Narayanji told about he breathe and live with concrete. I also, like between and concrete together. So bituminous road, concrete roads. So you may have some questions related to why the potholes are coming on the Mumbai roads. So maybe please direct all questions to him. So, and maybe some of the question. I was scared actually. Dr. Yogini has brought question paper actually. I was really scared actually when I saw that, because usually we prepare question paper, give it to a student. So it is reverse now actually. So I'm waiting for interactions. Yeah.
Great. Thank you, Dr. Singh. So today's larger theme of, as you can see on the back screen, is advanced technology for construction, with a special focus on recycled concretes, using recycled materials in the construction industry. Concrete is the most used engineered material in the world. After water, concrete is the most used material in the world. I also say that concrete is one of the most forgiving materials, followed by bitumen. And this is because it is ready to accept all the types of waste materials that human beings generate, be it coal fuel ash, be it the microchip-related silica fume that gets generated, be it, what we'll be talking about in the panel today, be it PET bottles, that is water bottles, Bisleri water bottles. So if we are drinking water and throwing away the bottles, Mr. Narayan here was the expert on how to try to use those bottles. So when we look at concrete construction and sustainability, and using waste materials in the construction aspect, two things become very important. One is, how do we reuse the generated concrete waste in itself? So today, a lot of redevelopment projects that are happening. Many a times, older roads have to be dug out, and what do we do with that material that is being generated? So there's a reuse of the existing construction material in itself also, and aspect of using waste material in concrete or in bitumen. Now, the second aspect from a perspective of sustainability is the durability. How much is it going to survive? And how long will it survive? And what will be the cost for it? So these two aspects are something that we want to take forward in this panel discussion. And so my first question is to Mr. Narayan. You talked about graphene-based concrete. So this is something I think which is very, very new. Could you explain what is graphene-based concrete, and what are the challenges in incorporating graphene-based concretes in the infrastructure projects?
Thanks, Doctor. It's a very good question. It's a very new material to work with. I've always found from a lot of researchers that we have exited plastic age and we have got into carbon age. So I assume that from 2010 onwards, we have slowly started migrating to carbon age. Today you must be seeing a lot of carbon emissions, net zero plans, and so on and so forth. As our chair, Dr. Yogini, said, the second largest consumed material on earth is water, is concrete next to water. Now, if you see the consumption pattern of concrete is enormous. Now, the biggest contributor to pollution, emissions, pollution is concrete, especially during the manufacture, right from the cement stage up to manufacturing of concrete and transporting concrete, placing the concrete and everything. So there's a lot of pollution emissions going on with embodied carbon and all that. How do we reduce that? Cement, as such, it was quite a few decades back, it was around 1 ton of CO2 emitted per ton of cement manufactured, 1 ton of carbon dioxide emitted per ton of cement manufactured. Now it slowly came down to 700 kgs. The target is around 350 kgs with the low calcine clay cement, LC3 cement, which will come in the next few years. India will have LC3 cement. Now, but concrete, it's an over-designed concrete. So here we have experts here. The factor of safety is very, very high. Now, we don't want to produce roads which can fail. The concrete roads cannot fail. It should not fail. It should not get repaired often. So what do? Is we incorporate a very high level of safety. The high level of safety is basically more cement and higher thicknesses. Now we make sure that the thicknesses is more than what is prescribed because we want a safety factor. We don't want it to fail. Now by virtue of this, what happens is a more contribution to emissions. Now, graphene is a material which can be processed basically from waste materials. Like for example, I have rice husk. I can manufacture graphene from rice husk. And rice husk is a big problem in India, pollution creating problem, especially in the north of India. Now, graphene, when it is incorporated, engineering-wise, it can modify the composition of concrete by reducing the cement content drastically by around 60 to 70%. Now, you will have reduced emissions. Now, you can reduce by exploiting the compressive strength of concrete, you can reduce the thickness of the concrete member. Though you will have to work on the flexural strength and the split tensile strength, especially on ground-supported slabs or roads. So you will have to modify that. But there is a great prospect of using this new engineered material in concrete in the future. And for tall rise buildings, you can safely incorporate graphene in concrete, basically because it can give you very nice factor of safety. Basically, one is towards slender sections of columns and beams, and you can make use of smart concrete, engineered cement composite.
Thank you. So basically, it's an interesting thing that we are adding. So we started in the late 90s with coal fly ash and silica fume. In fact, one of the first silica fume used structures was something that I worked on, which was a nuclear power project at Kaiga. And from there, we've come to graphene, and I don't know what else we'll add. So that's why I said concrete is a very forgiving material. So my next question is to Dr. Dharamveer Singh. We are looking at different types of recycling materials, and you have a major forte in pavements. So can you throw some light on what are the different types of recycling materials that we could be using in the pavements? And in using these materials, what would be the aspects of QA/QC that we'll have to consider? Because clearly roads is a major pain point for everyone.
So thank you very much, Dr. Yogini. So I'm not sure like how many of you know what exactly the road construction look like, but in a very simple sense, you may think that it is just a kind of some material which is put up on the ground and then compacted and then road is constructed. It's not that straightforward actually. And if you see the material consumption, particularly for the road construction, is enormous. For example, you require aggregates, you require cement, you require bitumen, you require water, you require steels, a lot of different requirements. Now, if you see the way we are doing the development all over India actually, particularly road sectors I'm talking about, the material requirement is enormous. How do I really compensate it through some kind of local materials or some kind of like marginal materials? For example, in the morning there was a C&D waste was also there. How do I use that for the road construction? May not be for the high-speed road, but at least some urban roads, some local roads, definitely it can be used. Other thing is, the existing road, for example, you must have seen a lot of roads are failed actually, a lot of potholes there, deformations there, waterlogging is there. How do I recycle the existing material itself? So because material is already there, we are cutting the mountains, putting on the ground. So ultimately, now the mountain is within the ground actually. So how do I utilize that material? Whatever material is already being used, you can again recycle that. In fact, we have been promoting that recycling a lot now actually. Whatever on the ground, you can do the recycling, you don't require any kind of material. So one is the C&D waste, then the existing material. Waste plastic also we have been using a lot actually. So waste plastic, then you can think about maybe slag, which is coming up from the steel industries, iron industries, that also been going now into the construction. And biomass, for example, biobinder is also coming up now, because we have been, if you see the requirement of the bitumen in India, almost 8 to 10 million tons, that is the requirement of the bitumen, but we are not able to make all. So we have to procure from somewhere. So therefore, now the government is thinking about biobinder. How do I make the, excuse me, biobinder actually? So this I think there are different kind of recycling techniques are there. So we have implemented that. It's not like this is dream. We have already done that actually in many places in India, in fact in Maharashtra also. And we are promoting local bodies to utilize that actually. Thank you very much. So therefore, I think this is very good technique. In fact, if you need more information about recycling or any kind of techniques or any use of some materials, please do in touch with us, and we'll be happy to give some more input on that actually. Yeah. So.
Interesting, thus that we as otherwise are unaware of what the strides or the openness that the government has shown in terms of utilizing the recycled materials. I now go to Dr. Vishal Thombare, who is probably India's thin white topping man in sense of things. He has promoted this technique of rehabilitation very extensively and has been a major this in ensuring that MCGM adopts this technology. So my question to you, sir, is what are the advantages over traditional pavement rehabilitation solutions of using thin white topping pavements? And also, what are the, how does it perform in terms of sustainability and life cycle cost or maintenance cost?
Thank you, Dr. Yogini, for touching this point, because it's very, very important point. Before talking or before discussing on white topping, I will just roughly tell you, as Professor Dharamveer Singh has already told you how what are the different materials for construction of pavements and what are the new materials which can be used, as Mr. KRS Narayan he has also explained you. Basically, in Mumbai, we construct three types of roads. First is bitumen road, tar road. Second is concrete road. And third is now thin and ultra thin white topping. So mainly we are adopting these three types of pavements for construction. So normally whenever we construct any pavement, of course there are designs behind it. There are some field tests before designing, and after this field test we design, and whatever the thickness are there, whatever layers are there, then we construct accordingly. So whenever we construct bitumen road or concrete road, as per the design, we excavate everything from the existing surface. Then we roll the whatever excavated material. After excavating, we roll it. We put different layers. In some cases, depending upon the CBR, we put murum or some other layers. Then after that we put GSB. We just lay GSB, which is nothing but granular sub-base. On the top of GSB, we lay WMM, which is nothing but wet mix macadam. Till this layer, concrete and bitumen are the same. Above that, whenever we are talking about bitumenous layer, we put on WMM, dense bitumen macadam, and the wearing course is asphaltic concrete. So this is the typical cross section of asphalt pavement. For concrete pavement above WMM, we lay DLC, which is nothing but dry line concrete, and above dry line concrete we have a top wearing surface which we normally term as PQC, which is nothing but pavement quality concrete. So these are the two typical cross section of concrete roads and asphalt road, flexible pavement and rigid pavement. Now, as we all know that we do lots of research. We take help of IIT Bombay, CRRI, and we introduce different materials which matches to our environment, and as regarding sustainability and durability. So after lots of research, then we came across this new technology, which is nothing but thin and ultra thin white topping. Thin and ultra thin white topping is nothing but it is an concrete overlay. As we having asphalt overlay, in same manner we are having concrete overlay. White term is nothing but, since concrete is grey in color, so they term as white, and bitumen is black in color, so they term as black overlay, and this is white overlay. Basically, in this technology, we don't excavate anything. We are not laying any layers, which I told you that we lay GSB, wet mix, DLC, and PQC. In this technology, because years the traffic is flying on that particular pavement, so the below layers are compacted, consolidated. So we use the residual strength, and we just mill the top surface bitumen, and we lay a thin layer which varies from 4 inches to 6 inches, 100 mm to 150 mm. So there are few advantages. Number one, the thickness is reduced, because when we excavate and we put all the layers, the thickness is almost varies from 800 mm to 1000 mm. In this particular pavement, only milling is done, depending upon the site condition, 1 pass or 2 pass. 1 pass is 65 to 75 mm, and after that, if we require any profile correction, then we put up DBM profile correction, and on the top we lay this thin white topping. Advantages is that number one, fast track construction. We call it as fast track construction because we are not excavating, we are not laying, rolling anything, only milling and putting the concrete layer. In Mumbai, we are using M60 grade of concrete for thin and ultra thin white topping, and after laying, we are opening for traffic after 7 days. In normal cases, after 14 days of curing, we open the traffic. Secondly, we use different types of mineral and chemical admixtures. We are using fly ash, we are using metacholine, we are using microsilica, we are using alkofine or binary and tertiary. Depending upon the mix design we mix, we are having some target strength, and accordingly we design the concrete mix design. We replace quantity of cement by fly ash or microsilica or any other mineral admixtures. And in market nowadays there are very good plasticizers available which enhance the concrete strength, or in some cases our RMC plants are just beyond Mumbai. So the time required, the lead time is about 1.5 hours to, as we all know, the concrete sets very fast. So we are putting some retarders so that it will not set during its travel time. What I'm trying to say is that nowadays materials are available, admixtures, mineral and chemical admixtures are available. So we can use these admixtures as per our requirement, and as in pavement, we design for flexural strength. As per IRC 58, whenever we reach 4.5 Newton per mm square, we can open for traffic. So that can be achieved in early days by putting different types of material. Now, life cycle cost. If we compare life cycle cost, because thin and ultra thin white topping, these all are rehab techniques. So whenever we put this particular technology, when we construct pavement with this technology, it lasts minimum 25 years as compared to asphalt overlay. It may last up to 3 years, 5 years. So if we take life cycle cost, then of course it is cheaper. What we had calculated, 25 to 30% cheaper. Thank you.
Thank you. So basically, using these methods, we'll be able to also reduce the cost of the rehabilitation. Now, typically, all the new techniques that Narayanji mentioned or Dr. Vishal mentioned, in construction, introducing a new technology is not like iPhone. कि iPhone अभी I don't know 16, 17 आ गया तो next day there's a line outside. I'm sure there are many product companies here, and even Dr. Vishal and Narayan would agree that when they introduce a new product, it's not like there is a line outside ready to buy the product in that sense of things. And so there is this humongous research cost and also an acceptance cost that goes when you are trying to introduce new materials. I mean, even if it's recyclable, we understand that this material has to be used. We understand that bitumen or concrete is a relatively forgiving material. I mean, we would not be able to, accept recycled materials in many other, let's say in automobile manufacturing. Recycling is not acceptable over there. The safety gets reduced from that perspective. So construction and concrete, basically, is something that we need to understand and appreciate, that the cost is not just about manufacturing or doing the research, but also the acceptance cost, because it's not an easy acceptance cost. What happens, what I've typically observed is government officials will say, "Aapne ye kahan use kiya hai pehle? Use case hai kya?" So these are the different aspects that need to be considered. So now there is a newer material another technology that is being introduced into the industry, which is large-scale use of PET bottles, plastic bottles in concrete. And I would request Mr. Narayan as well as Dr. Singh to comment on it.
You nailed perfectly. I can tell you with my experience, 22 years in Reliance Industries and having launched 3 brands, acceptance was a very, very important thing. I know Recron 3S fibers way back in 2003. People said, no, I will not buy because it's extra cost. Today it's being used. Acceptance, everything. It basically boils down to commercial acceptance first. Kitna cost padega? The first thing which a consultant will ask is, kitna cost padega? Nobody cares about what material you give, because concrete is a commodity today. Now, anybody going and saying my concrete is better will not be bought. Every concrete is the same. It's how you go sell yourself. So the basic thing was getting acceptance to it is basically towards improving the efficiency of the end material. That's concrete. Now coming to the point of PET. Now, India is the largest recycler of PET bottle in the world. Reliance is the largest PET recycler in the country, in the world. 75% of PET bottles in India is recycled by Reliance Industries. So we have set up a robust infrastructure to pick up PET bottles from throughout the country, from railway stations to the cricket stadiums to whichever point. No, there is, even if whatever you are having today and it's getting thrown out, this hotel will give it off to somebody who is connected to Reliance Industries, it goes. Now what we do is we have dedicated 2 plants which will shred this material, make fibers out of it, and then there is a brand in Reliance called RELAN. This is manufactured, this is a textile brand which is fiber which is manufactured exclusively from PET bottle. Now what happens to the balance 25%? Now this was personally bothering me as to how would we do away with the balance 25%, which is not recycled. Now government is saying ban plastic, ban bottles. Now, I have attended a seminar in the morning where glass bottles have been used. Instead of PET bottle, glass bottles were kept in the tables. It's a premier institution, it's a premier government body which is doing that. Whenever I visit CSIR labs, I'm greeted with glass bottles, serving water. They say, how do we dispose this PET bottle? Now, we found a very good way. What we do is we collect the PET bottle, we shred it to small sizes, and which is as an ingredient in concrete, basically bring it down to 2 to 5 mm thickness of PET. Use this because this PET is in concrete will not do anything other than work as a substitute material. Now, PET has a very high tenacity. So you have to exploit the tensile strength of PET fiber. Now, it's not the PET bottle per se which is used, it's shredded into small pieces, put inside. It can replace sand, it can replace natural aggregates by a long way. So, in my work which I am currently doing now, which will hopefully be published by end of June, that is around 30 to 40% replacement of aggregates in concrete. So, I am able to do that successfully because one, I get valorization for the PET bottle. There's a system which gets money by picking up the bottle. And there is a lot of employment generated in that. And concrete is one of the largest consumed material in India because infrastructure is growing at a very fast pace. Now, roads. Now, we can start working on roads basically as a material that can be used in stabilization of roads. You don't have to basically mine, as Prof. Dharamveer said, some mountains have become to the ground level now. That need not happen. I am also working on CO2 sequestered aggregates. Now, your fly ash, your slag, all this can be pumped in with CO2 and made as mineral aggregates. These are all artificial aggregates which can be replaced. So, a lot of efforts are being taken, and PET bottle in the next few years' time will become a normal situation which can be used in concrete. So, and also, we'll also make sure that India is hopefully being able to declare as 100% recyclable PET in the world. So, this is the mission.
What can we get some idea on what would be the QA/QC practices that we could adopt for
the road construction?
Yes. Road construction.
So, QA/QC, quality assurance and quality control, basically, this is, like how do you monitor the quality of the road constructions? And it looks that whoever is going to do the construction of the roads, they have the perfect plan in the action and they are going to monitor the quality. The problem is the material is material. Either you are using in India or you are using in the US or any other country. Bitumen is bitumen, aggregate is aggregate, cement is cement, machine is machine, money is money. The problem or the issue is the manpower. How do you educate your manpower actually? And we, we are sitting here, we are listening. How do you really percolate the information from top to the bottom level? So the contractor today, they have certain labor and they are going to do the construction, by the way. As an engineer, we can design anything. These are the fancy things we can design and we can give it to them. But the construction has to be done by the contractor, and contractor has to, give it to some labor actually. There is a problem. There is a lot of knowledge deficit is there between top to the down actually. And quality control, as you ask, is very serious issue actually. Is completely on the paper. It has been monitored, and if you go to any site, maybe some of you, those who are involved in the construction of the roads, the maintaining the records, the quality control records, looks perfectly beautiful actually. No issue in terms of any test parameters. All test parameters satisfy, everything looks perfectly okay. Then why the road fails? It's a very simple question actually. So we put a lot of emphasis on educating to the local bodies as well as to the ground staff actually. In fact, I visit a lot of sites, and first of all I ask them, I don't want you to train the engineers, they are already trained. Please ask your roller people, your plant people, your labor, ask them to come here and let's talk about them actually. What they're doing, how they're doing. So in the nutshell, if you really need to implement the quality control and quality assurance, please educate the root level people actually. Not your engineers and lot top people actually, but they have to be educated. They need to understand what is the value addition. For example, simple curing actually. Concrete road, कल बना है और दूसरे दिन क्रैक आ गया उसमें actually. There is no fault of design. Design was done perfectly fine, as Dr. Vishal was saying. The issue is how do you really take care of that actually, and why it has to be taken care. So until unless you really simplify the quality control and quality assurance in the very lucid language to the manpower, they are not going to understand. You are not going to tell them alpha, beta, and gamma and all actually. You need to simplify that. And this is the biggest hurdle that I find actually. How do you educate them?
So basically you're saying is capacity building is much the need of the hour. That of course, I think all of us are seeing it across the board, especially the newer generations that are coming in. Capacity building is going to be a major this. You know, my next question is to all of the panelists. Many urban bodies, and this was earlier also discussed, that you struggle with waste utilization and waste utilization in construction. So, but at the same time, there is also a bit of a constraint to use the waste utilization. So I would like all my panelists to comment on what is it that they would want from the urban bodies in terms of what, in terms of the acceptance of these newer technologies.
See, government is the biggest user in India. Now, infrastructure, construction, funding, everything's in the government. Now you have products. With my experience, I can tell you, we have waste plastics. Now, Reliance is the only company in the world to have branded a product. We have a product called Reroute. Now, the Reroute has been launched by Reliance Industries. It is only looking after the problem of littering of the multi-layered waste plastic. Now, PET bottle is very easy to collect, but the multi-layered waste plastic, I'll define it very simply. It is the chips packet, it is the chocolate covers, it's the biscuit wrappers, which is thrown. Now you have those small covers which are thrown out in the roads. It is littered. It's very difficult to pick because there is no value for it at all. So it all goes and drains the drain holes and stormwater drains, and we have problems during the monsoon season. You see a lot. It's basically because of those waste, littered waste. Now these littered material, they are actually multi-polymer. You have polypropylene, polyethylene, and polyester and all that, PET. You have multi-material, it's made out of aluminum also, so which is giving you the barrier for moisture. So, for example, your chips packet, it remains dry for a very long time because of the aluminum layer which is inside. How do you address that? We found a great solution. We segregated that. We made sure that it is basically ground to such a level that it can be used in road. We demonstrated all our plants have been constructed, all the roads in our plants have been constructed with reroute roads. And since 2020, that's 5 years, there's no repair, no pothole in any of the roads. All these roads are, they carry a huge amount of heavy traffic, especially the MEG tankers, which are of 35-40 tons weight, very heavy traffic areas. Nagotane, for example, it's a very heavy traffic. Nagotane, I'm sure, Raigad district is one of the biggest during monsoon. It pours around 400 centimeters of rain every monsoon. So nothing has happened to the road. Now the problem with the government, now we have been representing to all the bodies saying that why don't you use a product? But still what happens is the contractors come out and say, मेरे को cost नहीं देना है इसमें. कैन यू गिव मी वेस्ट प्लास्टिक विच इज 10 रुपीज? वो लेते नहीं है. दूसरा चीज है कि बिना लेके बिल देना पूछ ले, दे आस्किंग फॉर बिल. तीसरा चीज ये है कि ना द QAQC, it is there but it is not implemented. Now the engineer has to go and say, have you used a branded material there? I'm not talking about only a branded material. There, if there is an equivalent, have you used it? Show me the bill. Can you do a kind of a non-destructive testing to show me, cut a core and test me whether waste plastic is used? Nothing has been implemented. It's basically the job of the engineer, the contractor, and it is for the benefit of the citizens. Now, if I construct a road in Mumbai, I want it to last, at least a bitumen road should last at least 2-3 seasons. No, it doesn't happen. Every time we come out crying in the social media saying the roads have gone. So this is basically the job of the planners, government agencies to enforce it with penalties, and third is for the citizens to ask for it, saying that it's high time. In fact, I've been living in Mumbai since 2015. So 10 years and the same problem repeatedly, the water problem, again the roads are, see, there's no blame basically. The contractors have to change their mindset. So that's very important.
Thank you.
So basically, if you see in the government system, implementing anything new actually, it's not that simple, because the liability goes to the officer in charge. And if something fails actually, then that the officer in charge will be the responsible person actually. Why did you do that? The audit will be there. A lot of issues would be there actually. So the support system has to be there, which can really promote the implementation of the technologies, anything actually, whether it is new technologies or good constructions. And so support system somehow, it has to be strengthened first of all actually. Otherwise, as you rightly said, let's say some new phone comes up tomorrow, it will be implemented. It is not the case in the road sectors, because it's not possible. It's a heavy risk. For example, if you see the cost of the construction of a road, for example, concrete road, 1 kilometer may cost in crores and crores. So it's not a small amount actually. It's a big amount which goes into the construction of roads. And something fails, and then there is a problem actually. So support system has to be strengthened. And then there has to be system between academia and as well as government system to just make sure that the knowledge transfer is there, and then technological transfer is there. So that is very much required actually. Otherwise, things will keep on going like that. So somebody has to really think from the zero level actually again.
Yeah, very well explained by Professor Dharamveer Singh and Mr. KRS Narayan. Before touching these points, I will just like to brief you about what BMC is doing. We had made compulsory to use waste plastic whenever we are constructing bituminous road. And we had changed our policies. Whenever we approved any asphalt plant, so we just see that that asphalt plant is having attachment of waste plastic, so that whatever waste plastic we are getting, of course it is processed and it is shaded one, and as per there is IRC for using waste plastic 6% or something like that, and that proportionate has to be used while preparing the asphaltic concrete. So it is compulsory in BMC to use waste plastics whenever we are constructing bituminous road. That is number one. Number two, regarding aggregates, as Mr. Narayan, he said that we'll be using PT. In the same way, we are doing research on waste tire rubbers aggregates. So whatever tires we just throw in dumping ground, if we burn, then there are various toxic gases are produced which are dangerous to human. So we are just cutting these tires and in the form of aggregates, fine aggregates and coarse aggregates, and even in the form of fibers. And very soon we'll be using in pavements. So we have done all research work at our end, and by using different percentage of waste tire aggregates by replacing natural aggregates. So on one hand we have to preserve our natural resources, and on other hand we have to use this recycled material. So one is this waste tire. Second is we are also using CND, what sir was saying. Whatever concrete waste is there, we are just recycling, and we are taking all the aggregates out of this waste concrete, and we are reusing. In Mumbai itself, Godrej is having that plant, recycle plant, so it is very much in our city. The thing is that we do lots of research. We don't accept blindly any material, any technology in our organization, because it's a public money, so we have to use very carefully. So whenever any new material or any new technology comes, we just study that particular thing. We do some laboratory test. If it satisfies the permissible limit, then we construct some stretches, and we request sometime IIT Bombay to have a look and to guide us for that, what stretches we had laid on field, and we work closely together, and if they say yes, we can go ahead, then that particular technology or product comes into tender. So it's not very easy to introduce any material or any technology in tender. So lots of homework we are doing at our back end. Regarding training, we are training BMC engineers, we are training contractor engineers, we are training our consultants. These three agencies, they sit in one classroom. Normally the training are carried out in IIT Bombay, so that see, after awarding one contract to any contractor, so there is no difference between I'm client, you are contractor, you are quality engineer. We work as one team. Our goals are one. We have to do quality work, and for that QA QC, what are the different parameters? What are the specifications laid out in tenders? Classrooms are we do all classroom works under IIT or Premium Institute. Normally, since we are lucky to have IIT Bombay in our city, under Professor Dharamveer Singh, Professor KV Krishna Rao, Professor Solomon, they are very nice, kind enough that they guide us from time to time. And these engineers come to field, so having only one goal, having on same platform that how we have to construct the pavement. Regarding, now I'll come to Mr. KRS Narayan's point that, yes, as a common people, as a common man, we always see potholes, but it is not so. Just to brief you, we are dealing with 42 different utility agencies, whether it is optical fibers, high tension wires, petroleum, then our own water mains, sewer main, so Vodafone, Reliance, Jio, then Airtel, number of BST cables, Adani cables, total 42 utility agencies are there. In many cases, what we had seen, whenever we construct asphalt road, next day, I'm not blaming, next day, the utility agency come, they just dig the road. Now, whatever compaction we had done, it is just loose. So, if you are not reinstating the particular trenches in proper way, then problems are going to come, because we are facing heavy rainfall in our city. It varies from 3,000 mm to 3,500 mm every year. And in some parts of the city, we are below mean sea level. So whenever water is stagnated on asphalt pavement and the traffic is plying on that particular pavement, and on the same time high tide is there, so water is not able to go. So for that, if bitumen is there, then slowly it get distressed. So now we have to give solution to our citizens. So we started different technologies, plastic roads, then ultra thin white topping, concrete roads. By using all this technology, whenever we had constructed these roads by this technology, there is not a single potholes. We had constructed ultra thin white topping. 15 years has been. We had constructed 15 years before. You can see any road, there is not a single pothole. So thing is that we follow all the norms, but there are some practical difficulties. We are surrounded by sea. In some cases, during high tide, low tide, the sea water comes below the ground and it goes. So whatever material is below the ground, mainly the fine particles, it goes with the sea. And this process goes on from years to years. And one fine day, suddenly there is a big cavity and it's collapsed. Of course, we are doing tests on every interval. I'm telling you the practical things what we are facing. It's very easy to see that Mumbai are full of potholes. It is not. It is not. So we are continuously working hard to recover all these things. For utilities, we are constructing utility ducts, dedicated utility ducts for utility agencies, so that utility agency will not dig, it will not excavate the main carriageway. They will straight away lay their cables into that particular dedicated ducts. And if repairs are there, if new cables are there, they will use that particular ducts. And in concrete roads, we are doing stamping of ducts. Whenever a new person comes looking on that pavement, wherever that duct thing is that, so he can use that duct, means we are providing longitudinal duct, we are providing transfer ducts. The thing is that we are taking utmost care that citizens should not, they should not be offended by payments. We are continuously trying to improve our quality, and we really try hard. We really use different types of material technology to give best road to our citizens. Thank you so much.
Thank you, Dr. Vishal. And I think everybody in the room, when they go back, if there is another friend of theirs who was cursing MCGM, please remind them and give them the points that he has mentioned, because I am a citizen, and I also see work with the BMC as a consultant, and I see their problems, and I try and explain to so many of my friends also. They're like, oh, you work with BMC, can you tell them to get my road fixed at least once in my lifetime? And I try to explain to them exactly this, that these are the issues that they also face. They're very nice people, they're good engineers in reality. So I think with that, we'll move on to a Q&A. If you want to ask any questions, please.
Hello, yeah, good evening. So one question from my end, as in we are working in RMC industry, okay? We are optimizing our mixes. On the one hand, we have to look about our workability, strength, durability parameters, but it is not supplied till the mix is optimized and economical. Since you were talking about different materials we were going to use in future, but my boss won't approve it until it is cost effective for us as an RMC player. So these materials, how they would be impactful for us to supply to the customer?
Very relevant point. See, IS 456-2000. I do not know whether you were working in the year 2000. I was in the RMC company. You were born. I was working in an RMC company. In 1999, I was in Mumbai, RMC Group PLC, UK. That was my first RMC assignment. After that, I went to Aditya Birla Group. IS 456 has not changed. Now, the same mild, moderate exposures. The biggest problem we have is we follow that code in true sense. We have to, because that's a guideline. But we have not stepped away from it by utilizing smart materials and redesigning the concrete. Now, your concrete, I can assure you that I can produce a concrete which is M60 grade of concrete with 220 kgs of cement. Now, if you need costing to be established, all RMC companies are working on cost, because the customer acceptance is only the cost. M60, every RMC company in the world can provide M60 grade of concrete. Well, how costly are you? Or how cheaper are you? 1 rupee cheaper, I'll give you this. There's no loyalty. I know the industry very well. Now, if next month somebody else gives the 1 rupee lesser, the customer goes there and buys concrete from there. There's no long-term contracts and all that. Now, how do you make sure your concrete is better? Is by working on a lesser factor of safety. Now, the problem is we still follow the design parameter of 1.65 times standard deviation. Standard deviation is 5. Now, if I have 40, I need to produce 48 Newton in the laboratory. Now, why is that required? Now, in UK, they don't practice 5 as a factor of safety. They practice 1. Now, in UK, I design a 42 MPa concrete and I get 40 MPa, which is what is designed on the 28th day. Now, we are looking at 3-day strength. Now, you start using smart materials. Use QSIM analysis. You can Google QSIM analysis. There is a lot of facility available to reduce the carbon footprint, reduce the cement content. Cement is the costliest material. Try and use more supplementary cementitious materials.
Yes, so I think, yes, policy intervention, not just in terms of usage or those by the government is necessary, but just sort of closing, I think the standards need to be upgraded very frequently. Participation by engineers, by urban bodies, scientists, as well as those product managers into development of standards, participation in those development of standards and pushing them. So like he said, IS 456 is our Bible for the concrete industry. And I recollect, so I was on one of these as a student or a little, fresher in the industry. When 2000 came, there was a panel similarly that was being done by ACI. And I was on that panel as a fresher. And so it's 2000, and the earlier IS 456 was in 72 or 76, 78. So 1978, then the next was in 2000, and after that we are still waiting 25 years.
We are getting one.
We are getting one, but it's not yet gone.
No, it's 700 pages. No,
Yeah, so who's going to read 700 pages? Who's going to read 700 pages? Who's going to understand what those 700 pages mean, or also going to be a problem? But I think we've had a very good panel, and with that, I end this panel discussion. Thank you to all my co-panelists.